Hi friends, this is the Science Chef. In this video, you'll be learning about the IUPAC nomenclature of the alkanes, alkenes, and alkynes. Please go nowhere and we'll be right back after this break. Welcome back. If you have not watched our last tutorial on the naming of organic compounds, where we discussed the general principles of IUPAC nomenclature, please click on the link in the description to watch it. In this video, we will be looking at the naming of the acyclic aliphatic hydrocarbons in details with more examples than what we had in our last video. Before we continue, let's look at what acyclic aliphatic hydrocarbons are. Aliphatic hydrocarbons are non-aromatic organic compounds that contain carbon and hydrogen only. They can either be acyclic, example alkanes, alkenes, and alkynes, or cyclic, examples cycloalkanes, cycloalkenes, and cycloalkynes. On the other hand, aromatic compounds are compounds of benzene and similar compounds. Now that we know what aliphatic hydrocarbons are, let's name the following compounds. These compounds are alkanes because they are all saturated hydrocarbons. In other words, they are made up of carbon-carbon single covalent bonds. Hence, their suffixes will be -ane. In the first compound, the longest carbon chain consists of 3 carbon atoms, so the root name is prop. The methyl substituent is attached to the second carbon atom, which forms the prefix 2-methyl. Therefore, the name of the compound is 2-methylpropane. In the next compound, the longest carbon chain contains 5 carbon atoms. Its root is therefore pent. We number it from left to right because it is the direction that gives the lower possible sum of the positions of the carbons to which the substituents are attached, which is 2 plus 2 plus 4 equals 8, as against 2 plus 4 plus 4 equals 10. Since the 3 substituents are all methyl groups attached to carbon 2 and carbon 4, then the prefix of the compound is 2,2,4-trimethyl. So the name of the compound is 2,2,4-trimethylpentane. The longest continuous carbon chain in the third compound contains 6 carbon atoms, so its roots will be hex. There are 2 substituents attached to the parent chain, a methyl group and a chlorine atom. We number the parent chain in a direction that gives the chlorine substituent the lower number, since it has a higher priority than the alkyl substituent. So, from our numbering, the methyl group and chlorine atom are attached to carbons 2 and 3 respectively, hence forming the prefix 2-methyl-3-chloro. But that is wrong, because we did not take the alphabetical order into consideration. Therefore, arranging the substituents alphabetically, the correct name of the compound is 3-chloro-2-methylhexane. The longest chain in the last compound contains 4 carbon atoms, so its root is but. The 2 bromine substituents attached to the first and second carbon atoms, when numbered from left to right, give it a prefix 1,2-dibromo. So the name of the compound is 1,2-dibromobutane. Having known how to label the alkanes, let's name the next set of hydrocarbons. These compounds are alkenes because they are unsaturated hydrocarbons that possess the carbon-carbon double covalent bonds in their molecules. Therefore, their names will all end with the -ine suffix. In the first compound, there are 5 carbon atoms in the carbon chain without a substituent, so the root name is pent. The numbering of the chain must be from right to left because this direction assigns the lower positional number 2 to the first carbon bearing the functional group. So the suffix of the compound will be 2-ene. Combining the root and suffix, the compound is named pent-2-ene. From the second compound, the longest carbon chain contains 4 carbon atoms, giving it a root but. Numbering the chain from any direction gives the 2 functional groups the positional numbers 1 and 3. Therefore, the suffix of the compound is 1,3-diene, since there are 2 different double bonds in a molecule of the compound. The actual numbering direction will be the one that will assign the lower positional number to the chlorine substituent, which is 2 instead of 3. so the prefix is 2-chloro. Being a diene, that is an alkene that contains 2 carbon-carbon double bonds in its molecule, the compound will be named according to the format prefix plus alkane XY diene, where X and Y are the positions of the 2 double bonds in the molecule. Therefore, the name of the compound is 2-chloro-butan-1,3-diene. The third compound contains 7 carbon atoms, out of which 6 form the parent chain and 1 is a methyl substituent. Other substituents in the compound are the bromine, chlorine, and fluorine atoms. So the chain will be numbered from left to right to assign the lower positional number to the functional group, and that is 2. So the suffix of the compound is 2-ene, and its root is hex. The 4 substituents form the prefix 2-chloro, 3-bromo, 4-fluoro, 4-methyl, based on their positions on the chain. However, since the naming must follow the alphabetical order, then the correct name of the compound is 3-bromo, 2-chloro, 4-fluoro, 4-methyl, hex 2-ene. The last compound in this set contains 3 carbon atoms and 3 bromine atoms. The 3 carbon atoms make up the parent chain with the root name prop. Actually, the position of the double bond is irrelevant in this molecule because no matter where it is, it will always be bound by the first carbon atom. So it is not necessary to add 1 to the suffix, as there can never be a 2-ene in propene. Out of the 3 bromine atoms, 2 are attached to carbon 1, while 1 is attached to carbon 2, giving the prefix 1,1,2-tribromo. Therefore, the name of the compound is 1,1,2-tribromopropene. Now that we know how to name the alkanes and alkenes, let's name our last set of hydrocarbons. These are alkynes because they are unsaturated hydrocarbons that have the carbon-carbon triple covalent bonds in their molecules. Therefore, their names will all end with "-ine" as the suffix. From the first compound, there are only 3 carbon atoms in the chain without a substituent, so the root name is prop. Just like in propene, the position of the functional group is irrelevant as it will always be bound by the first carbon atom. So when we combine the root and suffix, we obtain propyne. In the second compound, there are 6 carbon atoms in the molecule, out of which 5 make up the parent chain with the root name pent, and 1 is a methyl substituent. Numbering from left to right gives the functional group the lower positional number of 1 and not 5. So the suffix is 1-ine. The methyl substituent is attached to carbon 3 and therefore forms the prefix 3-methyl. Combining the prefix, root, and suffix, we obtain 3-methyl pent 1-ine as the name of the compound. The longest continuous chain in the third compound contains 7 carbon atoms and 2 triple bonds with a chlorine atom. The presence of the dual triple bonds makes the compound a diene. Numbering the carbon chain from right to left gives the 2 functional groups the lower positional numbers of 2 and 5 and the chlorine atom position 4. With this, the suffix of the alkyne is 2,5-diene. Its root and prefix are hept and 4-chloro respectively. So the name of the compound is 4-chloro-hept-2,5-diene. The last alkyne compound contains 4 carbon atoms and 2 fluorine atoms. The 4 carbon atoms make up the parent chain with the root name but. Numbering the chain in either ways gives the functional group a positional number of 2 and the 2 fluorine substituents positions 1 and 4. So the suffix and prefix of the compound are 2-ine and 1,4-difluoro respectively. Combining the different parts of the name, we obtain 1,4-difluoro-but-2-ine. If you enjoyed this lesson, like this video, subscribe to our channel and follow us on our social media platforms. Thanks for watching.